with Storage Server is what we call a customizable out-of-the-box experience around clustering and creating high availability NAS appliances. So it's pretty amazing where, for those of you who've set up Windows clustering, they sometimes make it a joke, you need a PhD in 3 hours and a lot of documentation. What we've done with Windows Storage Server and that clustering, and I'm not going to take the thunder away from Scott, but we've greatly reduced the number of steps without even ever having to go to the second terminal. And one reboot and everything comes up as highly available storage server appliances. We work with our partners and put that, and it's primarily sold through the OEM channel, the OEM hardware and software. So our partners go and take the software and actually add additional functionality and build out NAS appliances. And these are actually NAS appliances that are optimized for file serving. You have scenarios where you have IT consolidation and you can run things like Hyper-V and application workloads onto the storage server. So if we take a step back though, and we look at what the storage server family looks at today, we are looking at 3 particular segments. One is we have all the way from small business NAS all the way to highly available NAS or enterprise NAS. Some of the key product capabilities that we have, obviously, being part of the file services and storage team, we don't use the word CIFS. We like to call it SMB2. Very different from SMB1 and from what you know as CIFS. If you'd like to know more about the differences, Scott's going to be talking about a little bit more, but we're also in the booth. Talk about the real differences between SMB and SMB2. 2.1 actually with Windows 7 and 2008 R2. There's a block storage with iSCSI software target. There are some interesting features specifically with 2008 R2 in the areas of data management with something we call the file classification infrastructure, which is very unique to the Windows Server platform in being able to classify files, doing data management on that level where we can now empower you to determine or classify files based on business value or what you tag as business value, and then you can apply things like either encrypting more files that require or contain more sensitive information, or on the other side of the spectrum is what to do with files that may contain or have lower business impact. Maybe move that out into more economical storage. Something that we're not going to cover in extreme detail in this session, but we have a good demonstration in the TLC area if you want to know more about that. Then we have the traditional technologies like DFS, DFS replication, namespace, and the ability to be able to do AD, Active Directory domain join. So in that areas, on one side is we have Windows Storage Server 2008 R2 Essentials, which is based on the Windows Home Server platform, but with Active Directory domain. So where you're going to start seeing some of the OEM partners starting to offer Windows Storage Server 2008 R2 powered small business NAS boxes. But what we're going to be covering more today is really more the workgroup, the standard, and the enterprise SKUs. And we have the workgroup, which has the iSCSI software target. We have the scale-up NAS, which is actually our standard edition, which we've enabled certain things that help the branch office, things like enabling a read-only domain controller and some of the networking features. And that's where you start seeing things like SIS, which is single instance storage. The enterprise SKU has exactly what we have in the standard, plus high availability and what I was referring to earlier, the simplified cluster setup, which we'll be going through in more detail. So we've also enabled hosted branch cache.
So Joel, why do we have 2 entries in the small business NAS category?
Thanks, Scott. Seems like a canned question. So the reason why we have 2 storage server offerings in the small business NAS space is, well, we wanted to effectively have one, but in terms of testing, we had one product where we wanted to get that simplified, very generalist console on that small business NAS. And on one side is we had partners that needed the iSCSI software target to enable block access. So we ended up with 2 SKUs initially in that small business NAS.
Right. And so Essentials really makes it super easy for people that have zero storage experience to be able to share files and use that really nice interface. Set up 25 PCs for backup. It uses that really nice little tray icon, so each person can control their own backup story. That is really nice. I think that those Essentials boxes are going to be pretty cool. But let's move forward. Let's talk about where the meat and potatoes is, storage server. So storage server, generally these headless devices are, as we said, pre-packaged by the OEMs. They're available for Workgroup, Standard, and Enterprise is only available in 11 languages. Essentials is actually available in 18 languages, the same language set that Windows Server is. We just recently added Brazilian Portuguese, which I don't know if you know this, they've had double-digit growth for like 17 quarters in a row, and I don't know how you can do that, but Brazil is going nuts. So we're excited to see a penetration there. But when you look at our OEM partners, they put together a really wide breadth of machinery. HP is one of our biggest partners, and they have a ton of different offerings, all the way from a small little tower form factor up to a dual node clustered situation where you can have multiple terabytes of data and very highly available, really nice infrastructure, hot pluggable, all kinds of cool features inside there. And it's not just HP. We've also got Dell. Dell has, if you go to dell.com/NAS, you can see that they've got 5 different offerings that run Windows Storage Server, including the new acquisition they did recently for Compellent. We've been working with Compellent for many years with Storage Server, and so now that's part of the Dell product line. So that's kind of exciting. Acer. Acer has a brand new entry. They only resell this through their partner network. But this is a really cool box that has those 12 drives up front. It's got just about everything redundant, so not a lot of points of failure in there. Really a nice looking box. Let's see who else is out there. Oh yeah, Buffalo. I don't know, I've been going to my local Fry's for the last 10 years and trying to find a Windows-based NAS. And every time I go in there, it's always this Linux thing. It's running Samba and CIFS, and it was cool. It did some stuff, but I wanted a Windows NAS. Finally, Buffalo came through with 4 different offerings for Storage Server 2008 R2. I think these are going to be pretty cool boxes. I hope to see that at my Fry's soon. And let's take it up a notch. How much metal can you put together in one package, and for what price? I don't know if you priced this out maybe even 3 years ago. You try and get 144 terabytes, you're over $100,000. This box doesn't sell much more than the hard drives cost. That's pretty cool, and that can put together a lot of storage. These guys are based in Europe. Joel, what are the customer challenges that people have with storage today?
Well, these are the typical challenges. Obviously, there's increased digitization of content. People are converting their files, digitizing their content. There's regulatory regulations, compliance that they have to deal with. And that's just one aspect. The other one is actually, it's essentially just the growth, the basic growth of data. We can see that in the size of the hard drives and what's been coming down. If we look at it from, can you click one more, Scott? If we look at it from of how IDC tends to look at it, is for the first time since 2009, file-based growth is actually outpacing block-based growth by a factor of?
3.
Oh, did you not have the animation in the slide?
6. Oh, I think did we? Oh,
there you go. So it's actually outpacing block by a factor of 3. So with there is still that focus and that importance of file-based storage as well. So.
Yeah, and I think this trend is probably going to continue on. And if you notice the amount of data being produced, I think in the next 3 years is supposed to outshine the last 20 years, which is kind of a mind blow. And I don't even know if they're going to be able to make that many hard drives. But now with 3 terabyte, 6 terabyte coming, I think maybe we'll get there. A lot of people ask, why should I use Windows Storage Server? Can't I just use Windows Server for my NAS? And the answer is yes, you can. You can use either one. But there are reasons why you'd want to use one over the other. The most prominent reason I know of is that a lot of people like to use Windows Server because they already own the hardware. And the thing about Windows Storage Server is that it has to be pre-configured on an appliance. So that is probably one of the bigger factors involved. But if you want to do iSCSI, just a month ago, you had to buy a Windows Storage Server appliance. Now, iSCSI is a free download as of a couple weeks ago. That is pretty exciting. And so you can put that on a regular Windows server. And the reason we did that is we wanted to be able to support Hyper-V with live migration so that you could have multiple VMs live migrate to your other Hyper-V host, and you'd be able to use an entire Microsoft solution. So you can put together a box, build an iSCSI target. It's shared storage. It supports persistent reservations, meaning it supports clustering. And then that stuff can fail over back and forth.
So let's, Scott, let me clarify that. And we always tend to miss that point because the iSCSI software target has been available for download. The additional is that you can download it and actually use it in production environments.
And that old version would only work on storage server, right? And now it'll install on everything.
Yeah. So, but the iSCSI software target 3.3 can only be installed on top of Windows Server 2008 R2. So that's
Yep. And a lot of people use storage server as a gateway to their SAN. You got a fiber channel card, you got a big SAN, but you don't have any file protocols up front. So storage server is perfect for that, especially if you're doing SMB and NFS. You want to do some web dev, some HTTP. There's all kinds of options to get in front of that SAN. So storage server specializes in those pre-installations, the rapid cluster deployment. One of the things that people really like about storage server is that there's no CALs. So you can deploy it into a lot of different environments, and all those clients, whether they're Windows or Linux or whatever, they can access storage server, no CALs. No big deal, no worry. Single instance storage is only available on storage server. It is the key unique feature for storage server besides some of our setup stuff, and I'm going to go through that. There are restrictions for using storage server. Microsoft actually offers storage server at a reduced price with additional functionality and no CALs than we do regular Windows Server. A lot of people aren't aware of that. That's how we can get the appliance cost down. The NAS space is very competitive. We want to help even make it more competitive, and so we drive that price down. And the way we can justify that is that there are some restrictions. And on Windows Storage Server, you can't really run SQL and Exchange and all your line of business applications. It's just really not meant for that. And in my mind, I think the problem kind of solves itself because you wouldn't want to run that stuff on your storage box. That'd be a little scary. So do storage for storage, and if you need infrastructure roles and the ability to install it yourself on your own hardware, then it's Windows Server. Okay, so a lot of people have Windows Server 2008 R2 and Windows 7 clients. When you put them together, they really leverage a lot of things, most notably SMB 2.1. I've got a R2 system at home and my Windows 7 client. I can drag and drop some files, and I'm getting about 115 megabytes per second. That's just about wire speed. I think maybe 120 megabytes is wire speed. I don't know if I can push it any further. And that's just an $80 Cisco switch in my home. That is an impressive number. I really love that. NFS, this is a really popular file sharing protocol for Unix and Linux environments. We have a NFS server in the box, and we have NFS client in Windows 7. We can use NFS, and you can talk to Windows servers, you can talk to non-Windows servers. Linux boxes can talk to Windows. Very happy, heterogeneous environments. Branch cache is very cool. Branch cache allows you to have either have a server in your branch, and one guy goes and asks for a file. It gets copied to the branch cache, and then the next guy asks for that same file. It'll get it locally. So it really saves a ton of bandwidth on the WAN. When you're got a lot of traffic over that WAN, you can save a bunch of money. Usually it's just cost per gigabytes, and you're paying a lot. So that saves a ton of time. And there's also the peer-to-peer cache mode in a branch office. If you have just Windows 7 clients and no server, the peer-to-peer cache mode allows you to get the file from another Windows 7 client. So that's really cool, and it'll save a lot of bandwidth there as well. One of my favorite features are the hosted redirection and the client-side caching. So this combination of having all my files on my laptop, and then I save a file to my documents, which is redirected to a server in my department. And so I save that file, and I go over to my server, and I open my documents, and that file is right there. I just saved it. It was just transparent. I have like 10, 15 machines, and every one of them, I open my documents, and my files are right there, always. It is magical. I don't even think about where my file is anymore because I know it's safe. It's being backed up on the main server. I have a copy of it on every client if I really need to get to it. It's just such a great feature. DFS, I think, probably the most popular feature in Windows file servers. You got 1,000 namespaces. You want to distribute those files over a bunch of different servers so finance and everybody can have their files, but they all want a single namespace. They want your whack company name, whack engineering or something. But you need that to fan that out to a bunch of different servers to actually host your data. DFS gives you that. Replication, really cool stuff. You can have 16 streams for replication that anytime somebody closes a file, it copies up the difference. So they got a 60 meg PowerPoint, you just change the title, it'll only have to copy the difference. So it uses that remote differential compression to pull out the blocks that have changed out of that file and blast them over the replicator. Very useful. And then, as Joel mentioned, we have FCI. And FCI is a new feature in R2 that allows you to classify files and apply policy. This is really, really powerful. You can almost do just about anything you can think of. If you can write a PowerShell script to do something to a file based on its business contents, based on your business rules, based on what folder it's in, whatever you can almost dream up, you can do with FCI. You can build a simple HSM solution. Say, take all my files that are a year old, move them to my SATA storage, and replace the file with a link. You could write that in about 2 minutes, just a simple batch file to replace that file and move it off. Everybody can still get to it. It just takes a little longer maybe, but you just saved a ton of money on that expensive storage. I love that feature. And then the file resource manager, file server resource manager is the harness that contains FCI. It also contains your quotas, your file screens, so you can block out files that you don't want on your server or set a certain quota for users so they don't go over that. Very useful stuff. This is what you would want in a file server. Joel, we have 3 main areas.
Yeah, it's just, the bottom line is as we kind of look at the technologies, we help our customers in the way that data is accessed, moved, and managed as far as the file services technologies are concerned. So this is just another way of looking at the file services.
Mm-hmm. Excellent. Why would I want to upgrade from 2003? I get this question a lot. I've got dozens of 2003 servers. What should I do with them? Should I upgrade? Should I throw them away? What do you think?
Definitely upgrade.
Well, actually, funny thing, I was at a HP conference last year, and they had an ROI schedule. If you buy this brand new Nehalem-based super server, you can virtualize 6 of your 2003 servers and run perfectly equilibrium performance. In 3 months, you could get the cost of that box back because of the power savings alone on those other 6. So sometimes throwing away old technology actually could be cost effective. Go figure. And the scalability, the performance, you can go bonkers with 2008 R2, put in a couple terabytes of RAM. Bandwidth management improvements. I don't know if you guys have seen this, but just by software improvements, by being able to shut down cores when they're not in use, and Windows Server has a 20% less power footprint. That's pretty compelling too. SMB2. So I don't know if you guys know this, but a lot of code at Microsoft has been written a long time ago. And it's kept on morphing and changing and people adding to it and building it on and going on. SMB2 was completely written from scratch. They started with a blank sheet of paper. And they redesigned everything from the bottom up so that they could support all kinds of new cool features. For starters, the number of scalable things is out of control. What is that number? That's 18 quintillion open files and users. Okay, well, I don't know if I can make that many files. Performance improvements, I'm going to talk about that in a second. A lot of the chattiness has been removed from the SMB1 protocol, where you would send down a packet, you'd wait for the response. You don't have to do that anymore. You can send a packet, send another packet, send another packet, wait for the response. We'll reassemble it on the other end. Very slick. And that made some huge improvements in the SMB pipe. We reduced the number of opcodes here. And this allows greater, more simplification, less attack surface area, quicker innovation. And we also support symbolic links inside SMB2 and 2.1. Here's what I was talking about on that chattiness. So you can see how the old version might take a number of round trips in order to get that packet across. Now we don't have to do that. We can just blast forward. Check disk. Often mentioned as the reason you don't want Windows storage. People say, oh my gosh, if I have to check disk this volume, forget about it. Well, there were some times back in the day when check disk didn't come back for a long time, maybe a really long time. But I can say now, very happily, that we've done some analysis, and with R2, we really rocked it. You can see here the number of hours it took to check disk a volume that had 300 million files. It's pretty good. And you can also see that it's not dependent on the volume size. So the number of files is really what matters for check disk, because you're really looking at particular metadata on those files. So we look at here, and you can see that it took less than 7 minutes to check disk a 15 TB volume, and that had 10 million files.
Yeah. So one of the key things to notice here, and to debunk that myth, is if you look at from 10 terabytes to 15 terabytes, a lot of people they assume that it's about the size of the disks, and then that's, they increase their storage. But it's actually going to be on the number of files. So just doing a check disk on the same number of files is about a minute longer from 10 terabytes to 15 terabytes. And there's when you get a copy of this deck, there is actually a very detailed check disk white paper on how 2008 R2 is actually able to leverage and maximize the use of the memory as it improves the check disk performance.
Right. So if you got 8 gigs of RAM in that server, check disk is a lot faster than it is if you only have 1 or 2. I think gigs of RAM are getting a lot cheaper too. DFS namespace. It is so much more scalable, so many more links you can handle. This is definitely well received by a lot of people. I know I have some server farms with million links, just some crazy DFS configurations, and the performance really has improved. This is one of my favorite features in Windows Server 2008 R2. And I don't know if you know this, but they improved the threading model that is associated that Robocopy can leverage. And if you do a drag and drop from Explorer, it's a single thread. You just copy one file at a time until you're done. If you run Robocopy /MT:128 in this case, or I kind of like to run it with maybe 32 threads so I can see some other things going on, but I can copy so many more files so much faster than ever before. And you can see this chart here. The more threads you do it, the faster it is. It's like 30 times faster on 128 threads to copy, especially if you have a lot of really small files. That is the way to go. Copying files. Everybody does it. One of the things that in Storage Server that we recommend for our manufacturers to do is to disable 8.3 name creation. 8.3 has been around for 30 years? I don't know. Yeah. A lot of reasons why it was around and why we keep it around is for certain application compatibility reasons. And now it's about the time that we can probably stop using that. So we recommend you disable it. You disable the aliasing on the file system. And there are some big benefits. If you're enumerating or creating files on volumes that have a lot of files, you get massive improvements in performance because we don't have to enumerate all those 8.3 names. Very cool. There's a tuning white paper mentioned on that URL at the bottom where you can apply these settings to your own servers. And you can even use tools to strip out all those 8.3 names. Very cool. So we've done some testing over the last year, a lot of testing. And we've tested a bunch of different systems and a bunch of different configurations. And we try to get some idea where we're at, what kind of performance are we getting. And based on a typical system for about $3,000, you can see the progression of where we were. Back in 2003, we supported around 1,200 users. 2008, we almost tripled that up to 3,200 users. And now in R2, that standard system is going to give you about 4,400 users. And this is concurrent access. Everybody in their whole place going whack, whack, server share and getting their file. Very cool. These are great numbers. We decided to test some other configurations. First of all, we started off with a 24 spindle. And this is an identical hardware. So we took SP2 2008, and we took R2, and we ran the exact same test. We almost doubled the performance with just software. So that means the networking stack is faster, the storage stack is faster, and SMB21 is awesomely faster. When you put those three things together, we get this number, and it is fantastic. We thought, let's crank it up a notch. What happens when you put 96 hard drives on that same system? This one has 72 gigs of RAM, which we're only using 17% of it. RAM is not a factor. We have 179 megabytes a second on my Fibre Channel HBA and SP2. The improvements in storage bumped that up to almost 419 megs a second there. And then on my 10 gig networking card with my fancy new R2 drivers, they really cranked up the number for the transfer speed on that network. And that gives us almost another doubling of speed there. And by speed, I mean number of users accessing files concurrently, and the file server has no hiccup at all. The comment was that we just released SP1. Does this number reflect SP1 or RTM? And the answer is this number is from RTM. But I do know the SP1 numbers are comparable. And, did I go the right way? Oh, that's the same thing. That's weird. Okay, we cranked it up. Now we created 192 spindles, 4 Fibre Channel HBAs in this system, got a bunch of trays of disks, and this is just a 2-proc. The CPU was running about 63%, the memory hardly any, 23%. We got it up to 23,000 users on a single box. I would dare any vendor to come up with a number like that. Anybody. On a CIFS, it's just not, I've never seen anybody even close. That is such a fantastic number.
Wow.
Hey, tell me about Emulex.
So something we were working on, it's interesting because that initial testing we had on 23,000 was just internally in our labs. A couple of weeks later, Emulex and HP were actually working together with some newer hardware and based on a very similar configuration. And our tests were actually running RAID 0. Their tests were actually running RAID 1 plus 0. So something you could actually use in a production environment. And they got somewhere in the area of 26,500 users. So we expect to see more and more partners actually being able to demonstrate clearly the file serving scalability that Windows Server 2008 R2 has.
Yeah, that's a cool white paper, and that was just published a couple weeks ago, right?
2 weeks ago.
Yeah.
Yep.
Check that download. I think that's going to be some compelling stuff. A lot of people are interested to know, how do we perform against Linux in our NFS performance? NFS is really quite popular. And I'm pretty happy to say that we have some really awesome numbers. Almost double the throughput of a standard Linux box for NFS on Windows. Most people do not realize that that is possible. There is some performance tuning white paper there. I talked about that earlier, and how the Linux performance tuning was done. We tested this in our lab. And because we're not a hardware manufacturer, we're not allowed to submit to the Spec SFS clearinghouse. So we did some testing internally just to find out where we sat. We couldn't publish these numbers, but we do know that we're right there, right with the big guys. And comparatively, you can see that we're getting some really good IOPS per disk, which is our kind of our final factor. You can see this NetApp 6080 here. They threw in 324 hard drives, and we had 24 hard drives, and we have a very similar number. That's pretty cool. I'm really starting to like the NFS numbers here, Joel.
Yep. I think a lot of our partners, and I think a lot of people don't think of Windows Server 2008 R2 as far as NFS is concerned, but we've been doing a lot of testing with our partners, and they're very pleasantly surprised to find that the NFS performance is either on par or better than some of the solutions out in the market.
Very cool. Okay, so let's talk a little bit about SYS. SYS is our dedupe engine. It runs at the volume level on files. It's not a block dedupe solution. It looks at a single file after it's been written. We come along and we take a look and see if this file has a matching hash in our hash database. If it does, then we check bit for bit on the file, make sure it's absolutely identical. And if it is, now we have two files that are the same. We take both of them, we replace them with reparse points. We take the original file and we move it into a common store, which is in a hidden directory on the root of the volume. Now, anytime somebody writes that same file into their home directory, we can safely delete it, replace it with a reparse point. It still maintains that location, all the ACLs of the original file. The metadata stays there, can be separate, can be different. And it's very slick. When a write comes into a file that's been deduped, we take that file out of the common store, put it back into its original location, perform those writes, and now it's a different file. And now it's a single. The question was, what if the ACLs are different? It absolutely stays different. The reparse points keeps track of what that metadata was. The ACLs, everything is exactly as the original user thought it was. And so you can imagine having a user home group folder situation where you have a couple hundred people writing to their home folder. Somebody sends out a 10 gigabyte picture and everybody laughs and they all save it to their home group. Now you got hundreds and hundreds of copies of the same photo. Well, we'll detect that. We'll go through the USN journal, and as we walk through that in NTFS, we see those duplicate files. We move that copy to the common store, put in those reparse points, and you're good to go. Save a lot of space. SYS is completely dependent on your duplicate data for its performance. So if you have 0 duplicate files, you're going to get 0 SYS. Okay? But I've seen a great disparity. I've seen servers that have single-digit %, and I've seen build servers that gave me almost 80, 90%. So sometimes at Microsoft, we run the build every day. You've got hundreds of duplicate files. We just create them over and over and over again. Perfect environment for SYS. Question? The question was, can we make SYS available for regular server and not just storage server? And the answer is no. We'll talk about the future later on in the year.
It's good to hear it from you, and obviously we always take input from our customers, and we're listening.
Yeah. We know there's a lot of people that want more dedupe, and we're certainly considering a lot of different options, so talk about that. SYS is really easy to use. Microsoft IT put it on their main product servers a few years ago, and we saved like 14 terabytes of space, which was pretty significant. And a lot of those release servers have 18 copies of every language on that file, and you only have to keep one of them. So very cool. There are some limitations to SYS. You can't do it on your system volume. You can't do it on files that have hard links. It does support now 128 volumes. The previous version used to support 6 volumes. We support clusters. You can do a failover of a volume to another server that's running SYS, and usually within an hour, SYS will come back and say, okay, I'm walking the tree again. So it's all kind of transparent. SYS doesn't try and take over the server. It will always back off if there's too much I/O going on. You can put SYS into the foreground mode. I'm going to show that in a demo here in a minute. There is a backup DLL for sys that a lot of storage backup vendors will use so that they can back up only one copy of the file. So we got Avamar and Symantec, and all these backup vendors are using the sys API so they can even further reduce the backup storage needed on that medium. Really slick. We don't do any files smaller than 32K. It's kind of an arbitrary decision, but you're probably not going to get as much benefit out of sysing 32K files when the reparse point is 4K and there's overhead there. Microsoft iSCSI Target. Okay, told you about the free download. Does everybody understand what Microsoft iSCSI Target is? Or an iSCSI Target? Nobody. Okay, let's go through it. This is really easy to understand in the fact that on the right, we have an iSCSI Target. This is running Windows Storage Server, or now Windows Server. You go into the iSCSI Target interface and you create a virtual disk. That virtual disk is a VHD file. That's our construct for that. But we take those blocks and we serve them up over the network as a container, a raw LUN. And then when you go to the initiator machine, you can actually mount them, format them in any file system you want, and do whatever you want with that data. It doesn't know that that is not a hard drive plugged right into the motherboard. It thinks it's just a locally attached SCSI hard drive. Very cool. You know, Joel, I think we should demo this.
Okay. Have you got a couple of VMs up?
Let's check it out. Okay. So here I am. I have two machines. I've got an iSCSI Target, and I've got an application server. On my iSCSI Target, I'm going to go and I'm going to create some storage. Right now, I've just got some space. I see that I've got an empty target here waiting. So let's create one. This is going to be my data. Oops. Okay, and this is going to be the finance department.
I think it's,
oops.
Scott, I think it's good to mention that, so there are two components as Scott's going through this. There's the initiator and there's the target. I think it's good to kind of point out that all the Microsoft clients, including the server itself, already have the initiator, the iSCSI initiator inside. And we're matching that, obviously, with the iSCSI software target. So,
So the best way to tell an iSCSI target which machine should I give my storage to, you want to be secure, you want it to be exactly the machine that you meant, is to go get the IQN. So the IQN can be pulled from the iSCSI initiator property dialog. It's right there. Okay, now that's the iSCSI initiator machine. Let's go back to the target. And it says, okay, let's put in that IQN. There it is. Okay, so now I have a container. It doesn't have any storage in it. It's just empty. But I have a container. I'm ready to serve up a target. Let's go create a virtual disk on that target. Okay, this is going to be my C:, my data. I can't type equally. Okay, every time. Let's do VHD. Okay, that's pretty simple to understand. I got a VHD file. How big do we want to make it? Let's go 10,000 megabytes. All right, 10 gig. Okay, finance needs storage. Next, finish. Okay, now we're getting somewhere. I've got a target. I've got a LUN. It is a virtual disk, and it's a VHD file that lives on my C drive. Hey, there it is, my data. Okay, that's pretty cool. I've set up my target. Let's go back to my initiator machine. Okay, so I want to connect to this target. Okay, so my target machine is named iSCSI demo. Let's do a quick connect. Boom, I'm done. 2008 R2 has such a cool feature, this quick connect button. You just give it what you want, and you can use a bunch of different ways to connect to a target. You could use the MAC address, you could use the IP address, you could use DNS. Right. Very cool. So now I'm connected. I've got a connection to my target. Okay, and let's go into Oops. Manage. Okay, I'm going to open up disk management and see what we got. Hey, okay. It recognized that I have some new storage. Someone just plugged a new hard drive into my computer. It's raw, it's blank, it's empty, it's got nothing in it. I can decide whether I want to do GPT or MBR. I'll just leave it at MBR. GPT would allow you to break that 2 terabyte barrier if you needed to. One of the cool things about the iSCSI Target is you can create up to 16 terabyte LUNs, because that is the file size allowed on NTFS. 16 terabytes, piece of cake. And then maybe 80 or 90 bytes less than that. Not a big deal. Okay, here I am. I have a disk. I want to create a new volume on that disk. Okay. Let's go ahead and give it the D drive letter. I'll format it NTFS. Boom. Okay, so I'm formatting some storage that is located on my iSCSI target. It's all mine. Done. Okay, I go into Explorer. I can see I have a D drive now. Very cool. It's got about 10 gigs. Okay, what am I going to do with this? I think I want to copy some stuff onto my new hard drive. Okay.
Hey, Scott, you have so you have the iSCSI software target available. So, and you have one client. What do we enable for Hyper-V actually once we have the iSCSI software target available? What are the scenarios we can play out?
Yeah, let's talk about some of that. One of the testing goals that we had for this Hyper-V iSCSI scenario is that we had a 2-node clustered back-end storage, and we wanted to support a Hyper-V cluster so that you could do live migration back and forth without any downtime. And I don't know if you know this, that if an initiator loses connection with its disk for more than 60 seconds, on 61st second, things start to go really south. You'll start to get some blue screens, some ugliness. It really starts to fall apart. What we did, one test, we had 96 VMs running on a single Hyper-V host, and we did unplanned failover, pull power plug. All 96 VMs quickly migrated over to the other node, and they all were still running. Not a single machine went down. And that was one of our design goals, is to meet that. And from now on, we use that as our bar. Every time we run a new test on the next build, we always make sure that we can support that scenario. That is going to be very compelling, I think, when you have really good quality backed up storage and you're able to do stuff. Okay, let's see, what else can I do that is pretty cool over here? What I want to show you is on an iSCSI target. Let's say you want to be an OEM. You want to start to sell Windows Storage Server. You can do that pretty easily. Just fill out some paperwork, come talk to Microsoft. We'll make you an OEM in no time. You want to build some appliances and sell them? This is how you would do it. First of all, I want to show you something. Okay, this is Windows Server 2008 R2 Enterprise Edition. Now I'm an OEM. I've gotten my package of storage server bits from the download site for OEMs, and I can see that storage server contains really just a bunch of packages. In R2, it is not an entire OS anymore. It is a bunch of stuff, and we give it to the manufacturer to assemble. Where in the past we might make a perfectly integrated DVD, now you'll start with a fresh copy of R2, straight up R2. You put in standard, you put in enterprise, and then you can start to build out a storage server out of it. You start adding in our storage components, our management components, and we also have a web RDP component that I'll talk about in a second. Okay, so I just installed Storage Server Enterprise, and let's try running WinVer again. Bam. This is now a storage server. Pretty cool. And I've got the proper EULAs, and I've got the proper licensing behind it. It is now no longer Windows Server. Okay, so that's pretty cool. What else have I got in there? I've got sys. I've got WebRDP, and I've got UBI. Those are 3 main components of a storage server that we build on, and then you also add iSCSI. So you put all that on, You do the registry key configurations we mentioned, get rid of that 8.3 name creation, you tune up your file server, your RAID array, and then the OEM would create an out-of-box experience. I'm going to walk through that in a second. Pretty cool stuff. Okay. So I've opened up my D drive on my new application server over here. And I want this to be a storage server too. But I want it to be running sys. Let's see. Let's get sys on this box. I can't activate. Oh, hey, I'm already installed. Perfect. Okay. So I'm running sys on this box. I have a D drive with a bunch of bits on there. What if I copy these and paste them? Okay, there's one. Let's do it again. Okay, so now Joe user in your company says, oh gosh, that PDF share has 1,000 files in it, and I really could use that in my home folder. You just drag it over there. And so did 10 other users. I'm starting to get a lot of data now on this drive. I need some more free space. What do you think, Joel?
I think you should run sys.
Yes. Let's try it. Okay. The command to control sys is called sysadmin. And what can you do? Boop. Okay. So I can take a look at my sys volumes. I can enable sys, or I can disable sys. I can install sys, and I can uninstall sys. Interesting but different terminology. And really, you could say, I want to stop sysing, but don't remove my sys. My files should be still sys, but just don't do any more. So you can set it to do that. You can also put it in foreground. So let's try this. First of all, I don't like this command line stuff. Scary. Let's use the UI. How about that? So I'm a IT pro. I know Windows. Let's go into share and storage management. That's how you share stuff. It's really easy to use. Okay, we get through here. I want to take a look at my volumes. I see that I've got a D volume. There it is, my new volume. Okay, I got 71% free still. Okay, let's go look at the properties of this volume. And when I jump over to the Advanced tab, I can see this little checkbox, which didn't exist before I installed that little syspack. Cool. So let's apply that. Now I've got sys running on the volume. Just that easy. The beautiful thing about sys is you set it and you forget it. It takes care of everything transparently. There's really not anything you need to do to it. It doesn't interact with you. Really cool. Let's go take a look now and see what's going on. Anything? Holy smokes. Sys has already found 11 duplicates in the last 30 seconds, and it's saving me 3 megabytes. Let's come back to this in a minute. Okay, so I set up a nice SCSI target. I formatted it. I put some cool data on there, and I deduped it. Okay? As I talked about, VHDs can be up to 16 terabytes. You can manually extend the size of a LUN. So if you have you want to keep it light, you want to kind of do a little poor man's thin provisioning, you give them 2 terabytes, you just add a terabyte whenever they need it. You got to stop the LUN, manually extend it, restart it. It's not while it's running. You can use VSS to create application consistent snapshots. This is really helpful. You got a SQL server. You want to do some data mining on there. When you go to take a snapshot, we actually go into SQL and say, hey, you better coalesce your data. You better flush your caches. Get all that stuff to disk. We're going to snap. And it gets ready. It says, OK, I'm going to hold all writes. You go ahead and snap. Bam. Now we got a copy of our data. I can take that data and I can mount it on my storage server. It's a static copy of data, a point in time. And I can do data mining on that snapshot remotely. Really cool. I can just log into it, and now I've got a whole set of SQL data to play with, and I can't impact the regular server. Pretty cool. We support a lot of cool technology in iSCSI, IPv6, fully supported. We do use CHAP authentication for our cluster, and we support VDS. MPIO, very, very useful if you have multiple NICs, and you want to load balance, and you want failover. That way it spreads the stuff around all the NICs, and if any one of those NICs goes down, all the communication flows over another one. We also support ISNS. I actually have not met 2 customers that use ISNS. I've only met one. ISNS is like DNS for iSCSI. So it's like a registrar of all your iSCSI targets. Pretty cool, and you can go and look up a target. It gets pretty useful if you have maybe a lot of servers and a lot of targets. You don't want to carry around a spreadsheet with you all day long. That service would be pretty useful. The new stuff in iSCSI Target 3.3, I don't know if you guys have been fans of iSCSI. In 2006, we acquired the company called StringBean Software. Actually, we acquired the WinTarget intellectual property from StringBean. All those guys came on to work at Microsoft. And we released basically 2 versions every year since 2006. And we've improved it and continued to improve it, adding support for PowerShell. And I think in R2, my favorite feature is differencing VHDs. And the way this works is you can create a master golden copy of your data, or a sysprepped image, say, and you could boot multiple machines off of that same image. And then each machine will start writing to its own diff VHD, which starts at 0 size. And as each machine comes out of sysprep, it could write to its own little container. And the way the differencing VHD works is it'll take the master and it'll take the diff data and it overlays the 2 and gives you that exact combination. So it's very cool how quickly you can build out an HPC cluster. I got some numbers to show you that are really awesome. Performance and scalability in R2 over the last version, over 3.2, we've almost doubled the amount of available resources now that can be used, and that's your NICs and your storage resources. Very much improved scalability and performance. Really did a great job on this last release, I think. The support for dynamic disks, that's from the initiator side. So on an initiator, I could create dynamic disks using my storage, fully supported, fully tested. So we've been looking at this opportunity where HPC clusters have hundreds and hundreds of nodes, and they want to do a Windows-based HPC cluster. You want to run some tests. You want to run some application, figure out the flow of water under a bridge. Some pretty hardcore computations need to happen. Well, today, if you want to take your 256-node Linux cluster down and put Windows on it, well, you got about 10 guys and 48 hours. I'll see you guys after the weekend is over. Pretty hardcore to switch it because you really who has time to go to every machine and switch it out? We came up with a scheme that is really clever. It uses a combination of PXE and gPXE and those differencing VHDs to create, in this case, I have an example here where we did 256 nodes. The deployment time is 34 minutes, and that means every machine came out of sysprep, got its own unique name, and is ready to run an HPC workload. Totally set up, 34 minutes. None of those machines knew anything about Windows before that started. And the way that we pulled this off is the HPC head node has a provider that they've written for us that talks to the iSCSI target. And so when you set up your HPC cluster, you go to your head node and you say, I want to create 256 differencing VHDs. It does it, all of them at once. Very fast to create all these different ones. And you'll note the subsequent boot time, from now on, after I have all my diff VHDs all out of sysprep and ready to go, I can boot into Windows in 4 minutes, 4 or 5 minutes. 256 nodes, all are diskless. None of these nodes have any storage in them. They all boot off of the iSCSI target remotely. That is radical. I can't imagine a world 10 years from now that has very many hard drives running on all these blades. I can imagine the data centers where you have silos of storage servers and all of the blades are humming along with nothing spinning. That sounds a lot better. I like that. Diskless data center. Whoa. Very cool. And we were talking about this, the synergy with Hyper-V. And there's really 3 ways to get some storage from an iSCSI target into Hyper-V and attach to a particular VM. In the first one, that is how you do live migration. You mount it on the parent. And when you mount iSCSI on the parent, you also get to take benefit of all the tow-enabled net cards. That can help speed up your performance. And so that is definitely probably the most recommended way. But if you have other manageability concerns, other different paradigms in your business, there may be a lot of reasons why you would want to pass it through or even just mount it all the way into the VM. So you can use the initiator running whatever version of Windows Server you're in that VM, or even Linux. Use that initiator to connect directly to your iSCSI LUN. So yeah, in this example here, we created a VHD file. That VHD file was presented to the VM. In the second one, we mounted the storage, but we didn't format it. We didn't do anything to that container. We just passed it through and let the VM grab that storage and format it. And in that third one, we go all the way into the initiator. Oh, live migration is so cool. How does it work? Well, it copies the memory content over and then keeps it synchronized. Bing, bong, all day long. And because we're using a nice CSV volumes underneath, the cluster shared volumes for clustering, it allows us to do live migration of multiple LUNs at the same time. If we get a failover, the second node picks up, it grabs hold of that storage, it knows exactly where those VMs are, up and running again. And using CSV, you can connect all these machines to your SAN, and it gives them that unified namespace. It gives them that ability to concurrently access a single file system. So the way they do that is very clever. We use a combination of SMB to communicate, and we allow the individual machines to have certain regions within the storage that they can read and write to. So in reality, no two nodes are ever writing to the exact same data, but they may be writing to data really close to each other. And that allows you to get that access to that whole file system. Why would I pick one over the other, Joel?
Well, that'd be good to know, Scott.
Well, obviously, I think there are a bunch of different reasons here. Sometimes the management is easy. Sometimes you want to be able to do differencing VHDs. You want to be able to get the highest performance possible. A bunch of different reasons. I think the most compelling thing you want to do is live migration, and so you would probably mount it on the parent. And I also like that because you get to take advantage of that acceleration on the net cards. We do have some recommendations, some guidelines. I ran into a guy today who has 10 gig NICs in his server, and I want to run some tests on his server. Okay, forget about 1 gig anymore. I mean, we're going nuts. That is going to be an exciting system. We definitely recommend having a physical connection for your iSCSI target. You don't really want to put that on your corporate network, all this iSCSI traffic. Just make a dedicated network. It's not that expensive. Uses all the same Ethernet that you're used to know and love. And we also do recommend that you could separate your random and your sequential workloads on different subnets. This will give you a performance gain, because when you're writing to a LUN and you have a mix of random and sequential, it has to do a lot of work. But if you put it all there, it can do a nice smooth writes on the sequentials, and the random can be focused on that workload. Sometimes people wonder multiple LUNs or multiple targets. You can do a lot of different mixes, and it really kind of depends on your management paradigm, how you want to set your boxes up, what your SLA is for your application servers, how much bandwidth, how much response time does it need. Jumbo frames, turn it on, it's fantastic. And then there's really no reason to connect the iSCSI to a virtual NIC if you're not going to, if you don't have to go all the way into the child. Just connect it to the parent. NAS UBI. All right, this is one of my favorite features. I'm also the PM on NAS UBI. This is an out-of-box experience. So we needed to give manufacturers a way to customize this box completely. You don't know what kind of array is running in there. And take a bare bones Windows server, you start assembling all the parts and you turn on the machine, well, you don't have the right drivers, you haven't configured your array correctly. There's a bunch of stuff the OEM can do to make that whole process streamlined. I'll show you that. it looks like this. You've probably seen this window before, or something that looked an awful lot like it. We actually took the old version and we spiced it up a little bit. It's got a little more punch to it. This is actually a WPF app. And it is completely configurable using a bunch of XML files, and developers can compile resource strings so that they can do all of this stuff in 11 different languages as well. Okay, so the title can be changed. You can put in your own logo, so it feels like it's your appliance. It's definitely branded. It's got your special tasks in there. Say you want to take someone to the web UI of your RAID controller so that they can configure some LUNs, and you got a nice placemat that tells you, step 1, step 2, step 3. Well, you don't even need the placemat. You just throw that away. You just walk through this app. It walks you through each step. You jump on the network. You join the domain. You provide a few simple steps, and you can create a 2-node cluster. So there's a standalone mode, or there's a 2-node cluster mode. And the 2-node cluster one, I think, is the most exciting one. As Joel mentioned, it does take about 3 hours to set up a 2-node cluster if you just take it out of the box and rack it and stack it and plug it all in and drink a coffee and wait for formatting and go to a domain, set up this one, go to the other box, I have to set that one up. You go back and forth about a dozen times, and finally, you're ready to click go on the cluster, cross your fingers, you go through cluster validation, and you're ready. Whew, that was a long time. What if I could just go to one console? What if I could just log in and enter all my data, and you take care of the rest and push it down to that other node? That's what we did. We've been thinking about this for a long time, and so we started building it, kind of one piece at a time. We said, well, what would it take to make it happen? Well, it turned out to not be very easy. It turned out to be a whole lot of different technologies that we had to use to make it happen. So the first thing that we did is we use a trick called image file execution. That allows us to trap the call to the regular UBI and stop that run. Let's go run our UBI. Well, it turns out that when you first power on a Windows server, there's no network. How the heck am I going to blast some stuff over the network to this other guy if there's no network started? Well, we trap that, and we kick off the networking stack. So now, before you get to Windows Welcome on a storage server box, the network is running. That's different than regular server. We also use a couple tricks for Windows UI automation. So we can capture the keystrokes and the enter stuff that they did on the Windows Welcome screen. We put all those keystrokes into an XML file. We transfer it over to the other node. The other node's sitting there going, hey, I wish an XML file would show up. And it sees one, and it blasts all those settings down. So now both nodes are in the same configuration. We also use technology called Remote App. You might have known this previously as like remote desktop application mode or something. This is pretty slick. So I can actually open UI on the second node locally. And we get rid of the whole frame. You don't have to log into the box. You don't have to see the start button. You can just go right into the applet for networking. We also use PowerShell remoting to keep things in sync. You walk over to one machine, you change the time zone. Sure would be nice if the other machine was in that time zone. We do it for you. Automatic synchronization. And we have this whole wizard framework, and it can be extended and modified by our OEMs. Let's do a quick walkthrough. So the first thing that you might see on this screen, if an OEM had loaded all 10 language packs, you'd see 10 languages here. And that way the end users say, hey, the very first thing they see is something in their local language. They're ready to go. I pick English. I say, oh, okay, I'm just going to click along, click next. I can also turn on accessibility settings. Everything works. When we first set up that first box, we launch a discovery operation. I want to know the IP address of that other machine. And the placemat that I took out of the box said, take this red cable and plug it into the red port on both machines. That's my crossover cable. That's my heartbeat. Well, while I was in there, I also plugged in my public network. I plugged in my lab network, and I plugged in some other network. And now I got all kinds of networks. But I can't launch discovery on every network, because how many machines am I going to have to go tickle? Well, that's a lot. So we do a little trick. We have the manufacturer tell us which networking port is going to be used for discovery. And that is going to be your cluster heartbeat network. A simple crossover cable. The very first thing we do is we disable every other network interface. We just enable the crossover. Boom, we launch Discovery. In a matter of seconds, we use the WS Discovery API set, and boom, we know the IP address of that second machine now. Now we can get somewhere. I accept my EULA. If I was a very clever manufacturer and I had one line in an XML file somewhere, I can make it a dual EULA. And I can put my own terms in there, and now I don't have to put paper in the box anymore. Very cool. That way, users, they like it when it's green. They don't want a bunch of paper in their box. Very simple to do, too. So you get both Microsoft terms and you get the manufacturer terms in one shot. So I'm cruising along in my UBI. I want to configure my networking. Well, networking can be very complex in some environments. It might take some serious understanding of your networking to be able to figure out if you're using statics or DHCPs and how it's all set up. So we let you go all the way in to the second machine, and we remote into it so you can actually see the network interfaces. And we would like to see manufacturers rename these so that it would be the blue port and the red port. This just makes a whole lot of sense. And you can do that now. You can rename every interface in 11 languages before the customer even boots. So it won't even say local area network connection anymore. Very cool. That way they know where they're at. So we go through this little wizard, the cluster name and domain join wizard. I just put in my domain one time, put in my credentials, I keep cruising. I want a cluster management name. This is the name that I'm going to use when I manage my cluster, and we automatically assign the node names of those two servers to be based on that management name. I put in my account information, my credentials, my local admin password, and now I'm ready. Okay, I hit the join domain button. It says I'm going to create these two primary nodes. I'm going to have this password, and it starts going. And one of the things we do is we always do things on the second node first. That way we can get some feedback from it. Are you done yet? Are you actually still there? We know we're getting feedback from that second node. We can trap errors. We can fix it. We can hope. We can kind of see what's going on, and then we can reboot our own node. We can change our name, and then we change the other node's name. We come and change our name. Very nice and synchronized. So it cruises through. It sets up the device, and then now I hit the final reboot, and I'm up and running. I have a cluster. Cool. Now I run the validate failover cluster wizard. This is also another wizard that's part of storage server, not in regular. And this will go through the standard call to validate cluster. This is just part of standard MSCS. I get a chance to, if I chose static IP addresses, I would get a chance to show them here so I could pick which interface I'm going to use. Makes a lot of sense. I have an opportunity here to not create a file server. If I chose, I could uncheck this box. But by default, this appliance is supposed to be a storage appliance. And what we've done is we say, we'll use the small container for that witness disk, and we'll use the big container for file. So if you just leave this checked, we're going to carve up that storage and use it for file. That way you can have a nice, highly available file server running. And if one of those nodes crashes, you're still serving files right off that other node, and that storage will just fail over. We give them a nice confirmation screen. You can see how everything's cruising along. And confirmation or failure. And we have done a lot of work making sure that we know every possible error that's happening, and we put it on your screen so that you can see what happened. And we have some recovery mechanisms, what we call the rainy day scenario. Oh, you were doing discovery of that second node? Well, I just pulled your NIC cards there, Bob. I'm sorry. Oh, we put that cable back in, and let's rerun it. Okay, then you can recover. It's not that hard. One of the other features of Windows Storage Server that is not in any other version of Windows, and a lot of people don't know about this, is that we have an RDP client that works in Linux on Firefox. Hey, pretty cool. So let's say you want to sell Windows storage into a completely non-Microsoft environment. All I got is Linux servers. I want to store some NFS data. But I don't want to buy another Linux server for that. Give me that Windows thing, which has that double NFS performance. Let's get that Windows box in here, and how am I going to administrate this thing? I can't log in because I don't have. It's headless. I got to get in there somehow. I can just go to HTTP server name desktop, and boom, full screen remote desktop. Whether I'm running Windows, whether I'm running Linux, all I have to do is go to my browser and invoke this URL, and I'll get the Java-based RDP control. So this is a Java control that was written in India by the terminal services team, and it uses exactly the protocol as they intended it to. It's secure, it supports SSL, it is a fantastic control, and you can just load that. What it does when you load it is it prepares a couple web pages for you, and one of those things is to dump that java.jar file into the client. Boom, full screen remote. You could also pull out a 1984 copy of Windows and get your Hyperterm out and a spare serial cable. That's where the real men jump in, and I love Hyperterm. Oh, gosh, that was a good time. Okay, sometimes that's actually necessary. You go into an environment where it's super locked down, you can't get into the box at all. You've got to have that serial cable and go in and set that IP address, because that's the first thing you need. You've got to have an IP address to get this whole thing working. Joel, we have some scenarios for storage server that are driving storage server, right? Let's talk about them. Branch office. How cool is this branch office scenario? You got a head office, you got a couple branch offices. What can I do?
Yeah, we have the, as we mentioned earlier, we have the, with storage server, you can consolidate storage in the head office, right? But there are things that we have in storage server where we've turned on certain networking features where it would make it ideal as actually a NAS branch appliance. Things like read-only domain controller and the networking features, the hosted branch cache, that'll actually help in the branch office scenario.
Right. So in this cool scenario, I've got a bunch of data, my user folders, and I've got some collaboration data that I want to publish to all my branch offices so that they can get to it. Super easy to set up, and nobody can mess up that published content. All of the users' data in the branches backed up and secure back at the home office. Nice. And all the services you can provide in the branch, you just put this one box in. You can run DHCP, DNS, all your file sharing protocols, iSCSI, make a read-only domain controller. Perfect branch office solution. And this thing is nice. It has a great price point, excellent performance. You've got a bunch of storage. You've got a bunch of different servers all over the place. This look familiar to anybody? It looks kind of like my basement. But I like it like this. Simple. You set up iSCSI. You got all your storage now can be on this 2-node storage cluster. It has failover. It has high availability. It's there. It's going to be there when you need it. And your application servers, clustered or not, can all access that data. Unified storage. I think actually maybe NetApp invented the word unified storage about 10 years ago, and we liked it too. We've been using it all ever since. And it really just means that you're running file sharing protocols and you're running iSCSI block protocols all in the same box. And in small, medium businesses, that is perfect because people really want to be able to serve up applications and users all from one place. We've got a lot of resources. We have a technical library. We've got a blog. Hey, did anybody read my bio on the TechNet site today? I encourage everybody to go do that. At least half of it is true. I want you to figure out which half, though. Okay, we did iSCSI and sys in 5 minutes. Let's go back and take a look at this demo. Okay, so I found that I had a gigabyte of data on here, and I copied it 3 times. Let's see what sys found. Nice. Holy smokes, it found 81 files now are in the common store, and I'm saving almost 2 gigabytes. Woohoo for sys. Sys just saved me a ton of space, and my users can drag and drop and copy all their data to their heart's content. I don't care. Let them go for it. Okay, so we successfully set up an iSCSI target. We formatted it. We put a bunch of data on it. We deduped it, and we're rocking. Definitely encourage you to check out some other sessions. I think a lot of these have happened in the past, but if you haven't seen Jose Barreto talk, definitely go to his talk tomorrow. He's repeating a session because there was so much interest. That is going to be an awesome talk. This consolidation of file services, everybody's doing it. Everybody needs to upgrade, and R2, it's definitely worth worth the money, and it's worth taking a look at if you're trying to upgrade from any of the previous versions. Got a bunch of cool resources. Please fill out an evaluation for this session. I want to hear your feedback. Thank you for coming.